In this video, I'm going to explain how to set up your Nuclides page 1 through 5 channel page. Now this should be your page VI. What I have done is copied and pasted the isotopes from Wikipedia so we can see them all in one place. For those of you who may not have it, the definition of a nuclide is a nuclear species is an atom characterized by its number of protons, Z, the number of neutrons, N, and their nuclear energy state. Is any species combination of Z and N and nuclear energy state that exists for a measurable period of time. It may not last long, but it exists for some period of time. This is the key that we are going to use, and I'll show you how to fill it out. But this is the species that goes in the center, the nuclide species. This is the percent abundance. This is the atomic mass. This is the half-life in its units, so in this case 129 attoseconds. This is the daughter or daughter products, these two. And these two are what's called the decay mode. And I'll show you where those come from the Wikipedia page. So we have Z, which is the number of protons, the atomic number, those numbers are 1, 2, 3, 4, 5. That makes this hydrogen. And this axis is A equals Z plus N, or the mass number. So we have 7 different nuclides of hydrogen, H1 through 7. So I am going to list those to start. H1, H2, H3, H4, H5, H6, H7. Now I am going to focus on H1. H1, we see it has 1 proton, no neutrons, and its isotopic mass, its atomic mass, 1.007825. We see it's stable. And its normal proportion ranges between these two numbers, 99.972 to 99.999%. Similarly, this next isotope, this one, goes from 0.001% to 0.00001%. Excuse me. Such that these two add up to 100, and these two add up to 100. So I'm going to put 99.999. Since hydrogen 1 is stable, it has no decay, and it has no daughters, and it has no half-life. And this is a stable element, so I am going to shade this green. Hydrogen 2 is also stable. We're going to move on to hydrogen 3 next. Hydrogen 3 is 3.016049. since it is not stable, it doesn't have an amount. But we could say trace. Now we see its half-life is 12.3 years. We see it turns into helium-3 by beta minus. And that's how I do item 3. I repeat that for all of the rest of them. And that's how I complete my chart of the nuclides. And again, that key I will leave you with is here: the mass, the abundance, the nuclide, the half-life, the daughters, and the mode.